Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. No, on the nature of Earth. I will get there eventually. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, before I shout out all the people who we are joined for, I'm going to do a quick shout out to all of the people who support me on Patreon. So massive shout out to Adrian Quintana, Alistair Main, Billy Highvolt, Burn Fat Till My Stomach Is As Flat As The Earth, Chow Young Cat, Dank, David Wayne Foster, Edwin Johnson, scroll down, Felix Hung, Fireball X, Godrockin, Jeranism, Kirsten Smith, Life Is Short, Matt, Michael, Page Love, Qatar Craig, Reinhardt, Renee, Sam Hine, Skeptic 936, Sweet Equity, Texas Mike, theflatearthchannel.com, and Tina Baker. Massive shout out to all of you for supporting me on Patreon. Now, we are joined in Google Plus by Arwin, Righteous Force, and 10th Man. I don't know where Flatzoid's gone, but hello, all of you.
Good morning.
And, have we got anybody on Discord? There's a couple of people.
I'm on Discord.
Oh, hello, 10th Man. I could have swore you were in the Hangout.
I was trying to get in, but it won't let me in. I'm trying.
Yeah, I've had a few technical issues myself this morning. I don't know, it's a weird day. Don't ask me why. I don't know. Couldn't tell you.
Hello.
Hello. Any signs of Earth curvature?
No.
No? Any signs of axial rotation of the Earth-based variety?
Nope.
None of that either.
Nope.
Scientific evidence of gravity?
Scientific evidence of what?
Gravity. Scientific evidence thereof.
You gotta get higher stuff, man.
Here's some mumblings from Discord. Any scientific evidence of gravity, though?
None
It's red.
whatsoever.
You gotta turn Redman up. He's got a crappy mic during the day.
No, man. I don't know if I can. That's as high as he goes.
As good as it gets. It's okay.
Important though that all those screws.
Yeah, next Thursday maybe sometime. Anyway, any evidence of a Good morning. Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
No, no evidence.
Maybe in the pseudo-Romanian realm.
What's for space?
Yeah. Maybe it's over there.
Maybe. Any evidence of the R value, Earth radius?
No such thing.
Discord, anybody?
What's up, guys?
No chocolate.
Hey, chocolate. What was it you called yourself yesterday? Oh,
God.
Don't remind me. It's on the tip of my tongue. You're talking about being chocolate. Was it chocolate helicopter? No, I know. It was chocolate airwolf.
Yeah.
Chocolate airwolf.
Yep.
No,
That's what I did.
10th man was. I was joking around in the comment section when people start bashing transsexuals, and I don't like it very much. Plus, I don't know, it's just not very nice. In any event, I just draw the whole thing down to a farcical level and say, well, as a proud black woman, I find the whole thing very offensive or problematic. And Chocolate said he identified as an attack helicopter, as you do, and decided he was going to be called Chocolate Airwolf from now on.
Now I'm gonna hear that
Yes,
music
I identify
every
as a
time.
chocolate airwolf. Thank you.
Right.
Yeah, that's it.
Great theme song, man.
They played it on the Alex Jones show for all the time for 2 decades. So
Yeah, no.
now I'm gonna think of you every time.
Shout out to Sean for the super chat. Thank you very much indeed. He says, hey Nathan. Hey. Any evidence that you can have gas pressure without the necessary antecedent of a container to press upon?
No way.
Oh, people in my chat started whining to me today about that. It was so annoying. Just couldn't let it go.
In what way?
Well, they just couldn't accept that an antecedent for gas pressure being a container was sufficient proof that our realm must be contained in order for there to be gas pressure. They just couldn't handle it. Kept on harping on about it.
Did you see the
Must be something in the
investigation?
water, because just about every action people do has a cause and effect. Why can't they accept that one?
I don't know.
Well, Truth Lover, I don't know if you saw me. I posted in Skype, and you guys were commenting. Some people commented if that's what it was. But the Truth Lover and I don't know if it was Zanuck or Kosho were saying that the new gas law is P equals, I guess, lower P R T. They removed the volume from the equation, so you can have pressure as long as you have density, gas specific constant, and temperature. So those are the new formula for gas law, by the way.
Oh, right. They're just inventing laws now, are they? So how does Boyle's law fit into that?
It doesn't. That's the point. It doesn't.
They're just rejecting Boyle's law?
Pretty much.
I see. That's very interesting.
So they're saying
So,
What did
so
they
they take a letter out of the equation and it all makes sense now?
yeah, and that's something else.
Adorable.
And you were on their Chocolate yesterday where they were talking like the way you get Newton and Einstein equations to work. As long as nothing moves at high speeds, it'll work, right? Remember that? Did you hear that on there? I thought that was funny.
Nah, I didn't hear that one. I must have missed that.
Yeah, so you can merge Newton and Einstein's equations as long as you remove high speeds from it. So Einstein only works at high speeds, and Newton only works at slow speeds. Changing the equations, folks.
What high speeds?
Well, like planetary motion, that kind of thing.
Oh, things that we don't have any physical confirmation of, you mean?
Right.
Okay.
And the new axiom from
So
Truth
what
Lover
letter
is basically saying as long as it works, so as long as the equation works, we're good to go.
So what letter did they take
And
out?
his
and what
name is
letter did
Truth
they put
Lover.
in?
That's adorable.
Yeah.
I like Truth Lover.
I mean, I think he's got some good
So,
information,
Paul,
and I don't disagree with everything, but some of the stuff I'm going like, really? Go ahead, Righteous Force.
Oh, I said my piece.
No, I was asking.
Oh, I thought you said that.
I was asking.
I was just shouting him out.
Oh.
I was asking what
He's one
letter
of the
did they pull
interesting-
out, and what letter did they put in again?
Okay.
Clover is an exclusive follower to the Betty Discord, but not on live shows. It doesn't come on live shows.
Any evidence of the distance to the sun?
Nope.
Nope.
There's no confirmed measured distance to the sun.
Hey, Sleeping Warrior. Nice that we can actually hear you properly today.
Yeah, I was out and about yesterday. I was busy running around and doing stuff, so I couldn't really join. I was listening, I just couldn't join. Balls. Catches in a sec.
No worries. Well, we got enough of Sleeping Warrior. I'm pleased you did join, even though it's slightly broken connection. That show goes out tomorrow, by the way. Slightly weird numbering's going to be the case over the next few days, mainly because I got my sister coming down on Thursday, so we're going to Warwick Castle, so I've slightly jigged the schedule around. There'll still be shows at the usual times, they'll just be on the other channel. So hence this is live today on this channel, and the after show will be at 10 p.m. on the Nathan Oakley 1980 channel. But yeah, things will return to normal next week. In case anybody was wondering, nobody probably cares. That concludes the housekeeping then, if there's no evidence of any measured distance to the sun.
No. Just R-based assumptions, pretty much.
It's been a while since we said the prayer for the poor departed globe.
Oh, that's great.
Radius
The
Dominus, Gravitas Spiritus Sanctus, Arwin. Go in peace, fundies, in R you trust.
Orwin.
No. Only Riley does that.
I'm incensed.
Good
You
job.
got that one, eh, Chuck?
Could be a bit quiet in Discord because the link didn't work, so I've just updated that in case anybody tried to get into the Discord server and failed. There's a new link, just refresh your page. You should be able to get in okay. Well, isn't this nice? You can have at least a 3-second pause in the conversation without certain conversation being totally dedicated to the lack of gas pressure. Given
The
that that's
calm
now
before the storm.
interesting that now that's fallen to the wayside, we've now got a situation where they're trying to remove volume from being part of their rhetoric. Interesting.
Oh,
Yeah.
Oh.
Anything
okay.
to remove the requirement of a container, it seems.
Same thing with R. They're trying to remove R from things too.
Yeah.
Well, this morning, thanks to trolls, I tried to look up atmospheric pressure and then gas pressure on my own volition. But Wikipedia doesn't even have a separate page for gas pressure, just pressure. And then I read through it, and scarily enough, they basically put pressure of gas pressure together in with pressure, like weight. It was like, what the? There's no more separate article for gas pressure. It's now been conjoined with weight pressure. Pretty freaky.
Really? We're discussing the subject in detail and how it doesn't work in their reification of a sphere model. You've got to make
Right.
changes, right?
Presenting it right now.
Got you up.
See, so here's pressure, just pressure. And this is basically, well, kind of gas pressure related explanations, even with the laws of thermodynamics. And then it moves on quickly into this kind of stuff. Wait, where was it here? Fluid pressure. Wait. What? Is this the same?
I certainly see V there.
Whoa. What happened? This doesn't seem to be the same article that I was looking through the other time. It's much bigger.
Maybe it's gone down the memory hole. Who knows?
Wikipedia keeps a log of any changes, so you can look up any change that has ever been made on a Wikipedia article. And you can even look back old pages, I think, from years ago, if you want to. It's at the top or bottom somewhere.
Oh, I say worst case scenario, you can go use a Wayback Machine, see if they changed it over the last few days.
What's up, Apollo? How you been, man?
Right.
Just returned
Yeah,
from vacation, and I haven't been on this show for some time. And people still think my voice is robotic, but it's a beautiful voice.
Okay. Can you pop yourself on
Anyway,
mute?
there's no mention
on,
within
hold on.
pressure of a container.
Oh, they've removed containers,
There
have
is a
they?
reference to the second law of thermodynamics. That's
Alvin,
when
what did you say? There's no mention of what? What did you say?
Container. Can you pop yourself on mute, Paul?
Sorry.
Alvin, what did you say? There was no sign off.
now within the Wikipedia article on pressure, which has conjoined gas pressure with all the other types of pressure, there is no mention of a container.
Yeah,
But
there is.
There is a reference where?
There is. Look on the diagram on the right hand side. Up.
What?
There's container,
mean
yeah, he's right.
Where?
It's at the top of your page on the right hand side, just above where it says thermodynamics. There you go. What does that say?
This?
Read the words underneath that diagram.
Pressure as exerted by a particle collision inside a closed container. Oh, right.
Yeah, there you go.
Well done, Alvin. Your comprehension skills are fantastic.
No, but I didn't read it within the actual text. It's just
That's
here.
fair
It's
enough.
just a little thingy. Let me try to find it.
Yeah, well, it's not a surprise that it's still the necessary antecedent.
The other argument too, a part of this is they're saying that the mass or the weight of the particle is what draws it back down, and equivocating because objects can fall down. So they're using, a dense object like a ball to equate that to a gas particle, and saying that's why it falls back down as well. So they're using a false equivalency as well.
Sure, I mean, they can ignore relative density all they like, but it's obviously relative to the medium that you're in. Certain gases might go down depending on what medium they're in.
Right.
If they're particularly dense gases, right? But that doesn't make them behave like tennis balls when they're in gas, which will go down because they're more dense, right?
Well, they're saying the vacuum is the no medium. So, and obviously the particle is more dense than the medium, so that's why it would fall back down.
Oh, right.
Yeah, that's our argument, though.
No, our argument
There's
is
no
that
word of antecedent in here anywhere.
It's the denial of gas behaviour. Isn't this interesting that arguments have come from the flat earth side, from Spurs and David, and now the rhetoric changes on the globe side? Isn't that fascinating?
Whilst
Can I
I was
ask-
looking for that, let me play a sound clip from Fight the Flat Earth recently. He was asked, how do you have gas pressure next to a vacuum without some kind of container? And obviously his answer is gravity, right? Now, bear in mind that he knows that gravity is not a force. Even if he wants to think of it as a force, it's still not a force. But listen to the way he dogmatically demands that that's the answer. It does contain swearing, so I guess if you've got small children, you should. He only swears once. But let me just play this little clip. It's only about 10 seconds long. So he's asked the question, how do you have gas pressure without a container? And listen to his bloody answer. The guy's an utter moron. So here we go. Actually, I might not be able. Yeah, I'll put myself on mute. If this doesn't work, just interrupt me.
There's no mention of the word container in the
Hold on,
laws
Arwin.
of thermodynamics.
Arwin, it's just about to play a clip. Obviously, we're not going to hear the clip. You've put yourself on mute in the Hangout, Anthony.
System exists next to a vacuum. Gravity, you fucking retards. Gravity. Have you ever heard of fucking gravity? Gravity. Gravity!
I made a video of him with the sound note.
Wow.
Shoutouts to Sheeple.
I love that.
Yeah, it's 'cause he's-
in gravity, right? So now he's saying that gravity is the reason why the atmosphere, why the gas pressure doesn't burst off into space. But we know whatever we're going to have to ask him, what does he mean by gravity? Because if he calls it a force, then he's dead. So he must have his own interpretation of gravity here, because we know it's not gravity doing it, because it can't do anything. It's not a cause, it's an effect. Rumpus.
Well, I'm sure that if Craig has claimed that that's the case, he can demonstrate that, right?
Yeah, we need to know what Craig thinks gravity is.
Sure.
Everybody
That's
else
all right.
knows it's not
No
a
worries.
force, it's the effect.
I don't know why he's so angry about it. Just show us.
Yeah. Demonstrate it, you moron.
What was it he said? Fucking retard. Let's
Yeah,
have
gravity, you moron. Can I
Let's
play it
have
again,
a-
just for austerity?
Let's have a demonstration.
Please do.
Let's have a demonstration. Let's have a demonstration of gravity maintaining gas pressure, please.
And we have gravity on the Earth. So let's see us having gas pressure without a container. I mean, I can't. It was that guy the other day on what's it, Ranty's channel. I was asking him, how do you explain the density tower in that container without a container? He said, well, it'll be all over the floor, wouldn't it? I said, exactly. So you need a container. He's like, no, it just means that those particular liquids couldn't exist. I was like, yeah, because you need the container, right? There has to be pressure, like pushing against it and holding it together. And he's like, no, but I was like, come on, I'm not being funny and I'm not being rude. I'm being really polite. But how do you get past that in your mind? And his answer is gravity. And I'm like, but it's not a force. And he thinks I was being funny with him, and I wasn't. But that's the high level of dissonance that these people, they just don't have it. They just say, no, don't take my gravity away from me. And I'm like, it's not a force, dude. It can't do anything. It might be an effect of something, but it's definitely not causing anything. So whatever that thing is that's holding your liquids together in that container, yeah, that's our argument, isn't it? There has to be the container, otherwise it's all over the floor. He doesn't get it.
So he's claiming that the bending of a conceptual medium known as space-time is the reason gas pressure can maintain itself next to a lower pressure system. That's what he thinks.
One of the things I brought up to them yesterday on the Discord server was, if you want to prove this, you could technically prove it in a vacuum. Show me how gases will pool at the bottom of the vacuum chamber. And can you guess their response to that when I said that to him?
Go on.
Oh, you can't scale it. It's got to be scale. So the scale is
scale. Oh, I see.
Scale.
So what he's saying is the mere force that we could create, that not particularly even close to a real vacuum that we could create here on Earth, that when scaled up to 10 to the minus 17 torr, which is what they claim the sky vacuum is, they're saying that the reduced effects of gravity when you go higher up, they're going to actually make the 10 to the minus 17 torr of the vacuum less susceptible to the gas wanting to conform to gas behaviour and expand in all directions. And the second law of thermodynamics, where it's going to want to fill that space, the available space, the space that MIT describe as gas wanting to fill, if it's available, which it absolutely is, because there's no container, according to them. Just an open system next to a really, really, really empty space for that gas to just, well, fill. But apparently the gas has got sentience and it gets to the sky and goes, I think I'll stop here. I'm going to stop behaving like gas. Or to put it another way,
the guy in chat.
Just to put it another way, just to put it another way, that's nonsense. The sky is not a vacuum. If the sky was a vacuum, the gas would fill the available volume.
There's a guy in chat and he's just said, we give gravity the power by talking about it. Right. The more we talk about gravity, the more it becomes it's a reification, isn't it? Talking about a conceptual thing as though it's real. And we're all arguing over it. Yeah, we have to remember that these morons can't prove gravity, right? Whatever it may or may not be. There may be something there, right? We do have an observed phenomena. Things do move, and it seems to be all by themselves. But we can explain that with a little bit of salt and egg and some water.
What things move all by themselves?
Well, normally when you make something move, you have to push it with a force.
When I make something move, you just said they move all by themselves. What do you mean?
Yeah. So when you push something, you interact with the object.
You said they move all by themselves. I said, what do you mean they move all by themselves? And you go, when you push something.
Well, actually, you interrupted me and I hadn't finished.
My bad.
So if you push something, you interact with the object, and with a push or a pull force, you can make the object move. But I demonstrated with my salt experiment that just by manipulating the medium, the egg moved. Now, what the reason for that is debatable, but we know what it's not, because we didn't manipulate the claim that is gravity. We didn't manipulate gravity. Gravity simply inferred. Well, that's not the cause. You can't infer causation in scientific method. So if something made it move, we know what it wasn't. We might not know what it was, but we do know what it wasn't because we didn't manipulate gravity. So you can't infer gravity did anything. But if you don't know what did cause it, then it moved all by itself. But we know gravity didn't do it. So who knows what causes it? But what we're trying to work out is why did it move initially? And when I asked an MIT professor called Jolyon Bloomfield, he thought I was being funny with him and stopped talking to me because he thought I was whatever. When I asked him, well, what made the apple move when the stalk originally snapped from Newton's apple? And he thought I was being funny with him, but he was unable to answer me. And I think that an MIT level professor should be able to answer what makes the apple initially move when the stalk snaps on Isaac Newton's apple falling from the tree. And he couldn't do it.
Well, part of that,
I've
I've said this on here before.
Really cool.
Even in your egg example, when you're pouring the salt into the container, you're actually adding kinetic energy to that. So the egg begins to move. So any movement, there has to be kinetic energy involved. So no matter what that movement is, even an apple growing up a tree, there's a lot of kinetic energy kind of causing things to move up. And then all of a sudden you release it, and the kinetic energy is released again, and it falls to the ground. They always forget that kinetic energy thing.
Yeah, they also forget the medium. That the medium exists. There is something there, and it is interacted in some way. There are explanations which we're working on in terms of real science, but at the end of the day, we know that it's what it's not because we didn't manipulate it. And for anybody to infer causation in scientific method, you're just a moron, and that's the reason why we know it's not gravity doing it because we didn't manipulate gravity.
I gotta add something on that.
Gravity.
Gas. Hello?
Shout out to fight the flat Earth.
Shout out, Troy.
Hello?
Well done.
Can you hear me?
Yes,
What's up,
man.
Tim, man?
Yeah. I was just I'm having some technical issues here, but on Nathan's statement about gas filling the available space, I just did a Google search about if you have a gas leak in your house, what is the advice from the experts? And one of them says, open all the doors and windows. You want to make sure you ventilate the house. Because now the house is a container for that natural gas, right? And there was a home that there was a gas leak and it totally blew up and 60 people were injured and one woman died. And they're trying to give safety tips. Well, one of the things is open all the windows so the gas could leak out of the container, the house. It's all over the place. You need a container if you want to hold it.
Yeah, if you look at how a carbon monoxide detector works, you always put a smoke detector on the ceiling of your house because smoke rises, but you put a carbon monoxide detector on the floor, or not on the floor, but low level on the walls of your house, because carbon monoxide is more dense than air, so it fills the room like water does from the bottom up. And basically what that does is they call it the silent killer because it often happens when you're in bed asleep. But the point is that the carbon monoxide is more dense than the air that you're in, and it fills it up like water. And because it's a fluid, because gas is a fluid and it behaves like a fluid, that kind of explains an awful lot when you realize that the carbon monoxide detectors are at the bottom because they're detecting carbon monoxide filling the room up like water, even though it's a gas.
I've been talking with somebody that is making a big vacuum chamber for his job, and he just finished, I think, several weeks ago. So, and we're discussing some experiments we can do in this big vacuum chamber he has made. So that's something that's going to be interesting to record and publish on YouTube. It takes about 15 minutes or so to make a vacuum and 15 minutes to close it. Well, first, it takes about 15 minutes to put the lid on 10 another 15 minutes to suck all the air out. Got the photo I can actually post at the Discord if you want.
I've already kind of talked about the first experiment you could do. Can you show in your massive vacuum chamber how gas can pool at the bottom of it? That would be great. How would you prove that?
The only way it can pool at the bottom is if there's a medium in there already. If it's in a vacuum, it'll fill whatever gas you're using will fill the available volume and it'll become the medium.
I know, I get you. I'm right on track with you, Anthony, but this would be their way of showing that what their argument is why we have this pressurized system based upon the density issue of the gases that would prove that. If they could prove that in a vacuum chamber, that's all I'm saying.
Yeah, they won't do it because if it's a true vacuum or it's a strong vacuum, there is nothing in there. So when they put a gas into it, the gas then becomes the gas then becomes the volume, rather than becomes pooled at the bottom, because there wasn't anything in the first place. And we know that it'll fill the available volume. It's only when it's got gas in it, then it'll pool at the bottom, because there is a medium for it to interact with. But if there's no medium, it'll fill the available volume and become the medium.
I don't have the exact specifications of the chamber right now, but the person uses it for something with plasma. I think he uses it for plasma welding. Actually, let me check really quickly what he uses it for. But
So Zinda,
That wasn't
Linda?
Cinder, it was Apollo.
Oh, Apollo.
all right. He uses it for testing prototypes at different atmospheres on temperatures, and he uses it for cold plasma, night riding, and a few other things. He has a workshop where he makes mechanical parts. I'm not sure what he makes, but he said he would love to. One of the things he's working on is a rocket engine, so he can test it in the chamber.
Well, the only problem with the rocket, as soon as you ignite it, there's this thing that is produced by a rocket called a gas. It would fill the space.
Yeah, it thrusts
Yeah,
off the
but
gas in it, and it also acts on recoil. It thrusts off itself, so it does create a movement, but it's a minuscule movement, and it's definitely not thrust.
well, that's what we are going to test. And if you put it at the bottom and it's pointed up, because it's a cylindrical chamber, it isn't a cube. So if you put it at the bottom, it shouldn't touch the flame shouldn't touch the top. And about the gas, it is a pretty big chamber, so the minute amount of gas that will be created won't compromise the vacuum to enough to make it have an atmospheric pressure great enough to compromise the
No, but you do realize that any
observation, I
pressure that
think.
goes in it increases the pressure, right?
Well, very little, but if we can pump more air out than the rocket produces, then shouldn't matter.
You'd have to have the
I don't
vacuum
know.
running whilst you did your rocket tests, so that it was constantly removing the matter that the rocket creates.
Yeah, that's what I was thinking. The same thing.
One moment.
Anthony, your vacuum pump would have to be enough to overcome the creation of the gas in the system.
Can I ask a question?
Yeah, I will have to ask. I mean, we're still talking about each other about how we should conduct this observation. So,
with the vacuum pump running.
Well, it does work, but like you said, the rocket will create a gas. So we have to think about this. Maybe if we have a very tiny rocket that only creates a tiny amount of gas, and we pump it out faster than it's able to fill the chamber, then it shouldn't compromise the vacuum.
Yeah, as long as you got the vac pump running, and then it removes the gas that was created by the rocket, then you're only going to be left with recoil or like a minute effect from the gas that the rocket was creating whilst it was being created. But you're right, you'd have to keep it running.
Well, and the other thing too, you got to think about too. You actually need pressure for chemical reactions to occur. So you're going to have some
Well,
level of pressure.
the rocket nozzle has to be filled with a fuel and an oxidizer, and then of course you need an igniter, and this will create an expansion of the of the fuel inside this rocket nozzle.
Can I pose a question?
Yeah, go.
Yeah, sure.
Yeah. So 10 to the minus 17 torr is the number they give us for the vacuum in space. Space is infinite. Now, here you are talking about creating some kind of cylinder with sides, bottom, and top, which means a container. Then you're going to use a mechanical device to take all the air out. So it's not exactly mimicking 10 to the minus 17 torr with no sides. Your vacuum chamber has sides, top, and bottom. So isn't this fall under one of the control variables that might explain some of these anomalies that happen when you do a vacuum within a container, when space is not a container?
Sorry, I apologize. I was actually posting a photo of the chamber, and I got this. I didn't listen to you, sorry. I was posting a picture. Can you repeat yourself? Sorry, I'm sorry.
Wow, that was a long one.
In short, he just said, how do you do a vacuum without a container?
Well, we will... Also, this is about the other experiment that... observation. Well, we will use the vacuum inside the vacuum chamber, and then we will put all the equipment inside it. So it will be we will observe it inside a vacuum. Of course,
but my question is for equal opportunity. 10 to the minus 17 torr in outer space does not have any bottom, sides, top. So you've got to recreate 10 to the minus 17 torr to match the real vacuum of space that they're saying exists. So you have to do it without a container.
Well, I don't know the exact specifications of the chamber, so I can't tell you right now.
You haven't listened to his question.
You're missing the point. There is no specifications in the vacuum of space. There is no sides, bottom, or top in space.
Yeah, how do you have a vacuum without a container?
Well, we can't conduct this observation in space because it doesn't exist. And
thank you. That's my point.
Yeah. So we need to create an artificial vacuum. Otherwise, there is no possible way you can conduct
artificial vacuum using a container that doesn't exist in the space vacuum. How's that ever gonna work?
Well,
to be fair, Tenth Man, I think he's actually showing humor. He got the gag.
We obviously can't create a vacuum as strong. I mean, that's whatever. We can't create a vacuum as vacuumous as they say space is, but we have to do the best thing we can do with human technology, right? So
okay. So then, whatever your findings are, you're going to have an asterisk saying this is done with a container and does not mirror anything about outer space.
I will.
That's a good point.
Your comment has been duly noted and will be published in the YouTube video. Yeah. Can I actually use your this audio sample then? That would be funny.
Yeah.
Yeah, go ahead.
Yeah, okay. Yeah, so obviously we need to get an artificial vacuum. So there's no other way around it. Unless journalism makes a rocket that goes to space, then we have to do it on Earth.
But do you see the comedy of the whole thing? In their pseudoscience space program, we send rockets up into this vacuum of space that doesn't exist. But for the time being, let's say it does, to make the comedy happen. The ISS is a container with oxygen in it so that the vacuum of the supposed space doesn't take all the oxygen. You're trying to do the opposite test here on Earth by creating a container and putting a vacuum that should be outside the ISS inside the container. Both need a container. It's so comical.
Well, you could make a small international space station and then put it inside our chamber and then have it rotate around a ball.
That would be fantastic. Make
That
sure you
would
don't
be.
have any wires showing.
No,
Well, and the
no,
other thing
you'll,
too,
They got one already. It's just in a pool.
well, even
yeah,
on the other side, if
we
you
will
did,
also put the vacuum chamber inside the pool, so it can.
well,
Come
even
on,
if you did
chocolate.
that, you still have to scale it, because if you use the same thickness of skin that the current ISS is supposed to have, it would be scaled wrong. So you'd have to get the scale of the thickness of the skin down to that size to go in the vacuum chamber. So you're still having scaling issues.
Yep. Problems.
I know some.
Problems everywhere.
Yeah, I'm also talking with somebody who works in the aeronautic space industry. So if I want something calculated on spacecraft design, I can just ask him, and maybe he will do it for me if I ask nicely.
Apollo, are you still a ball earther? Right? What's your position at the minute?
I think I'm still a ball earther, but I haven't followed you guys. I haven't really followed this flat earth stuff in some time, I went on vacation and did some other stuff.
Okay,
Lots of other stuff
just
happening.
explain to me, why don't you have an issue with gas pressure and like the sky vacuum that Nathan says? Why does that not have an issue? Why is that not creating an issue for you that we have gas pressure next to a vacuum without a membrane of some kind? Why does that not bother you?
Well, the argument against this has already been said multiple times, and Nathan gets angry, I guess, whenever somebody does that. So,
what is the argument against it?
Well, that's the. I'm not gonna say it. Whoa, I'm not gonna say it. It will just be a repetition of so many other videos, and I don't want to get into that.
Yeah, but you're on the flat Earth debate, and we're asking how do you have gas pressure next to a vacuum without some kind of container? And you say there's an alternative argument, and I ask you what the argument is, and you say you don't want to say. Why is it that you don't want to say if you believe that what you're about to say is true?
Well, it is the up to a certain height we can measure a pressure gradient, but we can only go so high with things like balloons. So at some point, you would have to make a mathematical equation, and that isn't science according to some people. So
what's the counter argument for how you can have gas pressure without a container?
Because that argument would mean what you are saying would mean what you are saying would mean the atmospheric pressure is the same everywhere, because it has equalized because there is a container.
No, but you
there
understand.
is
No, so you're creating a distraction, which is to do with the atomic weight of gases, and we're not going down that distraction. What I'm asking is, what's the counter argument for how you can have gas pressure without a container next to a vacuum? How do you do it?
because there is a pressure gradient, and we know at which height there is this lower pressure than, let's say, ground pressure.
All right, that's
then
not
you
the
could
question I
say-
asked. The question I asked was how do you have the pressure gradient without a container?
Well, how do you have a pressure gradient at all? Because there isn't a container between the different pressure gradients.
So you at least acknowledge that you need a container to have a pressure gradient, right?
No. So let's say so you would need a container between 14 psi, 13 psi, which I think is atmospheric pressure at ground level, on 0 psi of the vacuum. You would need a container to get that, right?
Yeah.
Okay, so would you need a container to get a pressure differential between 10 on 0 psi?
You would need a container to have the 10 in the first place.
Yeah, you've got a PSI value. You've got a square inch value, haven't you? Square inch of what?
Pressure per square inch, yes.
Yeah, square inch of what?
I think of
the
air.
volume, isn't it?
Pressure per square inch of air, right?
Arsenic?
No, it'd be square inch of the volume of the container.
The volume of the... I don't follow. I think PSI is about air pressure, right?
Yeah, what does PSI stand for?
Pressure per square inch.
Or pounds per square inch, but yeah, so square inch of what?
The volume, Apollo.
No, inch.
Yeah.
Square
Per
inch,
square
right?
inch of what?
Well, it depends on the gas inside.
Inside what? A container, by chance?
Indeed.
So, to have a PSI value, you need a container then?
We were talking about pressure differential between ground level and a vacuum, not about the definition
No,
of
you were.
PSI.
And Anthony pointed out that you can't have gas pressure gradient without a container either, because a gradient with its multiple PSI values would also require a container. You can't have gas pressure gradients without having gas pressure, and you can't have gas pressure without a container.
So what's the counter?
So
Apollo.
Quite warm, isn't it?
Fairview Road. What?
Oh, some fundy rumblings, I hear.
Been up with the flat
Apollo,
Earth
come on.
debate
Just giving my
for
address
about
out.
3
Apologies.
years now.
Oh, sorry, John. Go ahead.
Have you been keeping up? I'm getting a bad echo, man. Have you been keeping up to date with the flat Earth debate for the past 3.5 years, Apollo?
Balls.
Of course.
I think Apollo. I think Apollo
Then
got cornered and left one day, and we never saw him again.
You,
Oh,
how
hold
in
on,
the
Anthony.
world? Oh my God!
Just quantum eraser, just a pop.
What compels you people to talk over me? Can anyone tell me that, please?
Stop moaning. Just get on with it.
I'm on mute.
Yeah.
All right. I asked him, has he been keeping
Hi,
up
I
to date
just
with
came
the
back.
flat Earth debate over 3.5 years? He said yes. And then
Oh.
the answer to the question, how can you have gas pressure without a container? You say gas pressure gradients? Are you retarded?
That
That's a
is what I
question.
said.
That is what you said, gas pressure gradients, right? So gas pressure gradients are delta
Yeah.
X. Gas pressure is X. How can you have delta X before you have X?
Good question.
Sorry, I'm really not good at math. So
Math.
not sure. Oh, you mean there shouldn't be any pressure at all, so therefore there shouldn't be a gradient. There can only be a gradient if you have a pressure which is only possible inside a container.
That's right.
Yes,
Gas
you
pressure
got it.
gradient. You have to have gas pressure before you have a gas pressure gradient. Yes. It's profound, I know.
I think I have been looking into this flat earth stuff 4 years, maybe 4 years, 5 years, something like that.
So 4 or 5 years in, I want to know how you get past this gas pressure without a container issue in your head. If you're going to say the G word, we're going to attack you straight away. You realise that, right?
But no, that's not what he's done. He's expressed his misapprehension about if you have gas pressure in the first instance, that would mean you have an even pressure, and because we have a gas pressure gradient, that would imply that we've got a sky vacuum. I don't really know the connection, but that's what he said so far.
Yeah, but he's ignoring the fact that gases have got atomic weight by asking that question.
Don't worry about that. Keep
it's
them on
a
the
distraction.
subject.
Okay, but he's already explained it. He summarised our point. So he said, your point being that you can't have a gas pressure gradient without having gas pressure, or as Quantum Eraser put it, you can't have delta X unless you've got X, delta X being gas pressure gradients, X being gas pressure. The original argument being, how do you have gas pressure without a container? And by virtue of a value assigned by Apollo, PSI, that denotes the amount per inch of the container. How does he get past it, Anthony? He doesn't. No fundy with a sky vacuum belief. Let's rephrase that. Those of you in the audience who believe the sky is a vacuum, otherwise known as outer space, cannot prove that which you believe. It violates several laws of nature. You need the antecedent.
I want Apollo to answer it, though. I don't want you to answer it for him. I want Apollo to answer it.
Right. So you can't have a gas pressure without a container.
Correct.
But wouldn't that also mean you couldn't have a pressure gradient at all?
Yeah, but we have a pressure gradient, don't we?
Let me. So a higher pressure will always feel a lower pressure, right? For example, if you have a box with 10 psi and a box with 5 psi, and you connect them together, they even each other out. The higher pressure,
Correct. Yes.
lower
Yes, that would be.
fills the...
Yes, that would be entropy. Yes, given enough time. Yes, that's correct.
Then your next question is, well, why is the atmosphere even? Because you haven't kept up the debate to date with the flat earth debate. That's why.
Yeah, but just he hasn't asked that question yet. So
Yeah, he's going to.
Given that entropy is directly proportional to time, and given enough time, what you assert is correct, and those gases would even out by way of entropy, is your next question, why aren't they even in our atmosphere? Is that your next question?
Yes, it is.
Okay. We are living in a dynamic system. The gases are produced at ground level, not in the middle of the sky, not at the top of the sky, but at ground level. So the highest concentration of gases is at ground level, where we see the highest pressure. That will get lower as you go up. There are also multiple dynamic systems at play. Carbon system, the nitrogen system.
Hydro.
Sorry, go on.
Hydro.
Yeah, the
The
hydrological
hydrologic
system.
cycle, the nitrogen cycle, CO2 cycle, 3 of the big ones.
Right.
Right?
So
So there's
many,
difference.
there's many
So-
dynamic systems going on in regards to gas. But
So
ultimately,
it's
they're
a different-
produced at ground level, where the highest concentration is.
So it's a false equivalence fallacy to take a box, which is a closed static system, and then say, well, the Earth should be that way too. No, we have a closed dynamic system instead of a closed static system. Understand?
So Apollo,
So
how do you reconcile the gas pressure point that I asked you about before? How do you get past this? Explain it to me. Come on.
well, it was the pressure gradient that I talked about that we are currently discussing.
No, my question is, how do you get past the gas pressure next to the vacuum point without a container? My question is not about the density gradient, which we can demonstrate and explain with real science that we can demonstrate on a small scale. It needs a container. So my question is, how do you explain in your own mind how you have gas pressure without a container?
Well, you can just keep this pressure gradient going unless you basically have a vacuum. So you can
You
just
can't
Where'd you get the
have
ga- where'd you get the pressure gradient from?
without a container. How many times we got to tell you?
You can't have the pressure gradient without a container.
and this but there is a pressure gradient because of the dynamic systems.
Cares about the pressure gradient. You can't have a gas pressure gradient without a container. Are you? Is my mic working?
Yeah, he's not listening, or it's not going in. It's one or the other. So Apollo, how do you have the pressure gradient without a container? Come on.
Just 1 second, Anthony. Is it your opinion, Apollo, that you can't that a gas pressure gradient would defy the necessity to have a container? Is that your opinion?
Sorry, I had to listen to somebody in my house.
No worries,
Can you
I'll just repeat what I
yourself?
asked. So, is it your opinion that having a gas pressure gradient defies the need for a container? Is that your opinion?
Yes.
Okay, so on both sides of the argument, you can check out either Good Times for All, GUDTIMS, number 4, ALL, for a demonstration of a gas pressure gradient, obviously with the necessary antecedent of a container. You can also check out Blue Marble Science, also fondly referred to as Hillbilly Blue Balls, with
The redneck retard.
with a demonstration of a gas pressure gradient. Again, with the necessary antecedent of a container. So on both sides of our argument, there are physical demonstrations of gas pressure gradients with a container. What we definitely don't have, though, Apollo, unless you can correct me, of course, is a demonstration of a gas pressure gradient, or indeed a gas pressure, without a container. So unless we can have a affirmative demonstration of a gas pressure gradient or a gas pressure without a container, we can firmly put our stamp on it being what it is, the necessary antecedent. You can't have a per square inch value if you haven't got something to measure a square inch value of. That would be the thing that it's pressing on. That would be the container. So in this regard, given that there are demonstrations on both sides of the argument of gas pressure gradients in containers, would you concede that you still need a container to have a gas pressure gradient?
Can you define antecedent for me? Because I don't know the words and I want to be on the same page as you.
Sure, like
Antecedent.
something which you cannot have without the other thing. So the antecedent for a steak would be a cow. You can't have that. Well, I suppose you could have a tuna steak, but presumably it's a
ribeye.
A ribeye, there you go, T-bone, whatever. One that's obviously come from a cow. Well, the antecedent for that steak is the cow. You couldn't have that steak without first having a cow.
All right, yes.
Well, gas pressure, the necessary antecedent to have gas pressure is a container.
Like having an arsehole to fart. If you couldn't fart because you didn't have an arsehole, you would want an arsehole, wouldn't you? Well, we're saying, well, we want to fart, and we have an arsehole, right? But how do you guys fart if you don't have an arsehole?
Right, let's heighten that bar, really.
Yes, and more importantly, the gas would fill the space.
Antecedent.
Yeah, he still hasn't answered the question, how do you have delta X before you have X?
Correct.
It's the same thing.
Well, we run over slightly, so I doubt we'll get an answer, but we'll give him one more opportunity, and then I'll ask people to stay tuned if they're watching on Nathan Oakley 1980. So, do you have an answer for the live audience? There's a good couple of hundred people watching Apollo.
Yeah, hey, could you listen? Could you stop
your
for 1
name's
or
not
2
Apollo.
minutes? Hey, I know that, but can you hold off for 1 or 2 minutes before you close out? Thanks.
So what he's saying is, so you're going to ruin this nice, concise point with either a nice prolonged silence, which will then get interrupted by a plug for probably Quantum Eraser channel. Am I wrong?
I'm not plugging anything. Okay. That's highly presumptive on your part.
Yes, it is. Go ahead, Apollo. How do you have gas pressure without a container?
We all had a nice thought train going on, but I actually, because of all the people talking on stuff on my other question, I actually forgot what you said.
Oh, no worries.
So
how
Nathan,
can you have gas pressure, gas that presses, without something for it to press upon?
Oh, actually, I just remember you were talking about some experiments done by both sides.
Answer the question first,
no,
then
no, you can't detect it. I detect his tone. I know what he's doing. Okay, would this be a mercy plea, Apollo?
No, but you asked. You were talking about the experiments done by both sides that used a closed container.
Not experiments, but yes.
I was thinking about that, thinking of an answer, and then I forgot what I was talking about because I asked another question and people were talking.
Okay.
My memory is very good. So.
No, I don't mind picking up from there. So yes, there's 2 demonstrations that are easily accessible. One from Blue Marble Science, where he puts butane into atmospheric pressure in a pipe and creates a gas pressure gradient. There's also another one where the gas inside a container is heated at the bottom, cooled at the top to create a gradiated identical pressure. That's on Good Times for All. So there's 2 different physical demonstrations of gas pressure gradients within containers.
Yeah, really. Thanks for picking up. I saw the one with the pipe, but so according to you, it is a container, even though the top of the pipe isn't closed. I think, or is it?
Yes, that would still be a container. In the same way, if you've ever had do you drive a car?
No, I don't.
Have you ever known somebody who's owned a car with a slow puncture?
No.
Do you know what a slow puncture is?
No.
Slow puncture.
Do you know what a car is?
A slow puncture is where you run over a nail, for instance, and the tyre retains pressure but slowly loses pressure because the container, which it is, the tyre, it's still a container, has got a hole in it. Well, Hillbilly Blue Ball's pipe is a container with a hole in it. Like a tyre with a nail in it. So it effectively... Sorry, go on. Go ahead, sorry.
So what is your definition of a container then? What is your definition of a container then?
Will it be an enclosed surface that you can measure a per square inch value of?
So, well, an enclosed space, but if there is a hole, it isn't an enclosed space anymore now.
Yeah, it'd be an open container. Difference is open and closed. So in the case of an open container, it's got a hole in the top. So a fish tank, you could define as an open container. A cup is an open container. A tyre with a hole in it, or a pipe, is an open container.
So we're still back to the
All
question,
right.
Apollo. Go on, Apollo. How do you have gas pressure in the atmosphere next to the vacuum of space without some kind of containment? How do you get past that as a ball earther? Come on, just be honest. If you're going to say gravity, just say it.
Don't lead him.
You're too eager.
I know, but we've got no work.
Gravity!
Just calm down. Waiting for Apollo. I don't mind the silence.
Gravity, I guess.
Gravity, you guess. Is that what you said?
No.
Gravity, right?
No, you said density. I think is what he said.
Yeah.
What did he?
No,
Density.
I said gravity indeed. I mean, I screamed gravity. If you want to be
Oh,
accurate.
is that you? I thought that was Arwin.
No.
But is
No,
gravity your
that
answer?
wasn't
Is
me.
that how you...
But it,
The reason why I'm asking is I want to know what your brain tells you is the answer that you accept. If you accept gravity, then say gravity. If it's not gravity, tell us what it is that allows you to believe you can have gas pressure next to a vacuum without a container. Just tell me what you think.
well, it is gravity that's holding down the molecules. That's it.
Oh, it's gravity. So
Yeah.
you're flat Earth. Fight the flat Earth. It's gravity, you retard. Is that what you're saying? Right?
I screamed gravity, but it didn't say retard, so I get some points for that.
Let's give clarity again. Yes, that is what he said. He said gravity.
Okay.
For clarity.
And
hold on.
and-
Just hold on.
Oh,
Just for clarity. Apollo, what is gravity?
Yep.
Yes.
Gravity is yes.
Yes. Great answer.
Come on, Apollo. What's gravity?
I'm keeping the live show open for this. This is good.
This is very far apart. I don't know. I'm not a physicist. I leave that up to smarter people, smarter people like you guys
How does
to debate
gravity
about
interact?
it endlessly for
Hold
almost
on.
1,000 episodes.
Come on. What's gravity? We're not. Yes, we're holding your toes to the fire, but we're doing it in a nice way.
I don't know what gravity is. Sorry. I mean, some people say it's a force.
You
Some
believe
people
it.
say it's
You believe it.
bendy space-time. I don't know anymore.
Okay.
Sorry.
Should we
So I
enlighten
can't help you
then?
with that.
I'm happy to enlighten you. In this instance, modern day heliocentric worshipping nonsense is that it's the bending of a conceptual medium known as space-time, a place that doesn't exist being bent to cause a non-force that you can think of as a force, but doesn't actually do anything because it's not a force. So that definitely doesn't hold gas pressure. So I know your first answer was gravity, but do you have a second answer? Or maybe you're going to hold on to that first answer now. We shall see.
I guess an open container of some kind. I guess.
Yeah, an open container. Well, no, it doesn't even have sides. It's like a marble. Your
like
world
a-
of sphere, that is, with the sky vacuum.
Jimbo Con says, who cares if it's a force or not? We know it's still there, so you can explain to a noob why it can't hold molecules down. Thank you.
Yeah,
Well, let's let George, the Pontiff Maximus of Globetardia, speak to it. And this goes back to the elongation of the show, Nathan. I was going to finish up my point, which you presumed I was going to use a plug, but he used the same answer as the Fat Earth did. But according to George of Globetardia, the Pontiff Maximus of Globetardia, there was a question put to him the other day by Adam, our Adam here. The question was, why does gas behavior with respect to elastic collisions not take into account gravity except when required to create a force field? George the retard of Globetardia's response. The gravitational field forces of gravity between individual molecules is so minute and so overpowered by the kinetic energy that it doesn't enter in. It's so insignificant. The gravitational forces are going to be trillions of times less than the kinetic energy of the molecules. It's just not going to come into play.
It's insignificant, like your dick.
Hold on.
Sorry, what?
So how the hell is that holding our atmosphere, though?
It's not. That's
That's
doublespeak.
retarded.
He's got a force that's so insignificant. This is total doublespeak.
So, how does the gravity hold the atmosphere on the Earth?
We've already covered that. It doesn't.
I want him to answer, though. I know you've covered it, but I want him to answer.
Because
Well, it's not okay to just believe shit.
He was
no
just about to
evidence.
answer.
Well, I've been told it is because gravity is holding down the molecules and they combine in weight down to our atmospheric pressure, but I can't test that. So unfortunately, I don't know. I can't
So it's
really
a
help you
belief
with
then,
that.
right?
I'm not really knowledgeable on the subject of physics.
So would you agree then it's a belief, you just accept it because you believe that it's true for whatever reason, right?
No comment.
Apollo, you said you're going to do a demonstration for the vacuum chamber a friend of yours is building. You are proving in an opposite way what we're saying. You need to create a box or cylinder, seal it off from the atmosphere here on Earth, and then somehow pull all the atmosphere out of that box or cylinder to create what's known as a vacuum. Notice you can't do it without the box or cylinder. Now, what we're saying is we have an atmosphere that would go in every direction if it was meeting the vacuum of space. But if it had a container, it wouldn't. This is not clear to you?
Yeah, it is. And I think you know what I could say, but I don't want to say it because then you guys you all go on the rant about it. Really, I'm just excited for that this vacuum chamber is finished and we get to do some observations and we'll publish those. And those are tangible things, everybody can do. And I think that's also really interesting and that's something I wanted to say.
So
I'm-
you're going to use a container. You're going to use a container to prove a vacuum. But when the container is needed to hold air in, you're going to dismiss that?
One step at a time.
You're living in denial.
Well, let him just build it, and we'll see. Maybe
Yeah,
he'll
can build
let
it,
us do little tests.
Oh
He'll do
no,
some tests for us.
I'm not saying don't build it, don't do demonstrations. Do it all day you want. I mean, you need a container to have no air, and you need a container to have air. What's he proving?
He doesn't realize he's proven that you need to have containment to do any of this stuff with gas.
Just ask Apollo
Maybe
one
he
last
will
question
see.
just before we
He
round
will
out.
see.
You can't create a vacuum without a container either. So
Hold on, just one last question. So, in your vacuum chamber, do you think it would be feasible for you to put, let's say, a marble inside that container, vacuum, my bad, and have it retain a gas pressure gradient on the outside of the vacuum that's approximately, let's say it's 1/10 the size of the marble itself? Do you think that would be possible?
Sorry, you broke up for me.
No worries, I'll just repeat it. So, in your vacuum chamber, would it be possible for you to use a piece of fishing wire, for the sake of argument, and suspend a marble in the centre of the vacuum chamber, and on that marble, not in, on the marble, would it be possible to have a gas pressure gradient? And if, let's say, the marble is 1 centimetre, could you have a 1 millimetre gas pressure gradient on the outside of that marble inside your vacuum chamber?
Maybe
Or any
we
gas
will
pressure
find
at
out,
all.
won't we? But how do you measure the pressure on the marble? You need a very, very tiny, very tiny measurement.
Barometer.
Hold on. Well, you tell me. how do you measure pressure?
There are different ways different devices with different mechanics that measure a pressure. There are electronic ones or analog ones, or
And what are they measuring?
Oh, hello. So I just want to raise. So basically.
What the hell was that? Was that an attempted porn?
Some troller. Hopefully.
Thanks for that.
Yes, thank you so much. So Apollo, just picture your vacuum chamber. Yeah, with a little marble in the middle of it. Do you think it would be possible to have any sort of gas attached to the outside of that marble inside your vacuum chamber?
Yeah, sure. Yeah, we can do that. Just need
really
to give it some time, you know. Yeah. Yeah, I will
What,
hold you on that.
billions of years?
I will
Hold
hold
on.
you on that.
You say we can do
Yeah.
that, give it some time? You mean we can do that in the future?
Yeah, maybe. Yeah, maybe tomorrow. Who knows?
Okay, so if you believe that that's possible, at a fundamental level you don't understand how gas behaves then. The nature of gas is that it will expand in all directions and fill the container that it's in. And the point of a vacuum chamber is to... Hold on there, Apollo. The point of a vacuum chamber is to remove the gas. So you're saying inside your vacuum chamber, something designed to remove gas, you can have a marble suspended in the middle of it with gas attached to it, inside a device designed to remove gas. Is that what you believe?
No, I was just joking. There won't be a pressure around the marble.
There won't be. What about if that vacuum was an infinitely ever-expanding vacuum? Do you think that would make it more or less likely for that marble to retain gas pressure on the outside?
So it's bigger, basically.
Yeah.
So
if you've said that no, inside that vacuum, yeah, the gas would fill the space, right? Inside your vacuum chamber, the marble wouldn't have gas on the outside of it. It would fill the available volume. And if there's a pump on the outside, it would go outside the pump, right? Now I'm just saying make that bigger. So instead of a vacuum chamber, we're going to make it theoretically infinitely expanding. And we've got the same tiny little marble inside that vacuum. Would that marble be able to retain gas pressure on the outside of it?
No.
So what if I called that marble the blue marble? Would that be able to retain gas pressure on the outside of it?
Yeah, because of a 5-letter word. 5 letters.
Jeez.
But I'm not gonna say
There's
it
no
because then we will go on ranting about it. So
Yeah, there's no hope for him.
He's trolling.
He's circle jerking us.
Sure.
Apollo.
I don't want to say it because it has already been said so many times, and I think it's unnecessary.
But that's
what's the 5-letter word.
Wait. That's okay. Let me ask him a question. Does that marble have gravity?
No, that's not what I wanted to say, but if it's a really big blue marble, sure.
So you're saying that small marble does not have gravity, but the big blue marble does. Is that what you're saying?
The smaller marble has less gravity. It's a different sorry.
Scale.
Yeah, there we go. I knew that.
No, I wasn't gonna say that. I was gonna say something else.
Hey, Apollo. So tell me why in the current physics model no gravity?
Sorry, in what physics model? I couldn't.
Standard physics model use gravity. Why?
I don't know. I haven't read up on physics models, so I can't answer any questions about that.
Yeah, but
Okay, I think I'm going to call mercy on this. So if you do want to watch the continuation of this conversation, then you need to subscribe, if you're not already, to Nathan Oakley 1980, where this will continue on the after show. If you are watching on the Nathan Oakley 1980 premiering stream, then stay tuned, as there will be an after show to follow. However, if you're watching this on Nathan Oakley live stream, this is where we bid you farewell. A huge, massive, enormous thank you to all of you who tuned in, smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!